Okay, hey, 21 through 28. Okay, so, all right, we're moving along pretty good. Over what time intervals does the particle have a positive acceleration? Okay, well, that's going to be any time where your velocity is increasing, where the slope is positive. All right, so, and that only happens from 3 to 5. All right, so 3 to 5, and you could really say um, velocity increasing. Okay, okay, let me try this again. All right. So 3 to 5, and that's where velocity is increasing, increasing. However you want to say that. Over what time intervals does it have a negative acceleration? Okay, well that's any time that it's decreasing, and so negative acceleration is negative slope, and so that's just going to happen from 1 to 3, right? Negative acceleration from 1 to 3. This is it says 1 to 2 and then 2 to 3. 1 to 3. Yeah, I guess really there we have a cusp at 2, so so we'll leave it out. Yeah, that's a good idea. That's a good idea. But I was thinking it was going down the whole time, but it's wise to say. So I already forgot. 1 to 2 and then 2 to 3. All right, because there is a cusp in between. So 1 to 2 and 2 to 3. Great. Good. A cusp. When is the acceleration undefined? Well, anytime we have a sharp point, and we have 3 of those. 1, 2, 3. So undefined acceleration at 1, 2, and 3 because of the cusp. Cusps. So t equals 1, t equals 2, and t equals 3 due to cusps. That's odd. Okay, there you go. Oh, Lord of mercy. Okay, state an interval in time where the particle has a positive acceleration but is slowing down. Okay, I would need a positive acceleration would be a positive slope on this graph, but it would have to be where the velocity is negative. So I need a time where it's below the x-axis, okay, but has a positive slope, okay, because that would be slowing down. Right here. Okay, so down here we're moving to the left, but because your acceleration is increasing, right, it's slowing the particle down. It's pushing against it. Okay, we're moving to the left, but it's pushing to the right. Okay, so 3 to 5. That's a good way to say that if we want to. Okay, so from 3 to 5, because velocity is negative and acceleration is positive. And another way to think about that, I don't guess I have room to type it, but another way to think about that is you're moving to the left, but you're being pushed to the right. Okay, and so that's slowing you down. Okay. Go ahead and move. There you go. I know you want to. Okay, state an interval where the acceleration is negative, but the particle is speeding up. Okay, so we're going to the left and we want to be pushed to the left. All right, let's see which one does that. So down here, we're going to the left. We already stated that we're being pushed to the right here. This is pushed to the left. So we're going to the left and being pushed to the left from 2 to 3. Going to the left, push to the left. But the way you'd want to say it on the test is acceleration is negative, and so is velocity. They have the same sign. Okay, so from 2 to 3, velocity and acceleration are both negative. And again, you're going to the left, being pushed to the left. Okay. What is the particle's acceleration over the time interval 3 to 4? In other words, what is the slope? What is the slope from 3 to 4? Okay. Well, it looks like my rise is 10 and my run is 2. So 5, right? It's slope. So anytime you're asked for acceleration and you're given the velocity curve, it is asking you slope. Okay. And the rise over the run, right? And so for this particular one, we said what I already forgot. The rise was, it's going up 5 every time, right? So went up 10 and went over 2. Okay, so I'll say that. So 10 over 2, which equals 5. And this is feet per second per second. I can't do that on here, so I'll just do that. Okay. Yeah. I don't have a equation editor. So it's, but if you wanted to say feet per second, that'd be cool. No, I hate it. There you go. What's the particle's average acceleration over the entire 5-second time interval? So on this one, it's old school slope. Okay. So if it asks you the average of, the derivative, it's asking you to calculate. Okay, so I need to find the old school slope from 0 to 5. Okay, so at 0, all right, so here we go. This is x1, y1, x2, y2. Okay, so let's, do we want to say that? I think we do. So here we go. We started at 0, 5. I should type it. All right, I'm going to. I'm sorry. Go away. All right, let's type it. I'll do it down here. We're going from 0, 5 to 5, 0. Okay. All right, so here we go. Let's do that. Okay. So slope. So it's asking for slope from 0, 5 to 5, 0. Okay. And let's go ahead and do that. So it's going to be a fraction. On top, I'll do 0 minus 5. And on the bottom, I'll do 5 minus 0. The run is 5 minus 0. Okay. And so this is going to equal opposites, of course. So this is -1 feet per second squared. All right, there we go. All right, 28. What's the, over what time interval is the particle's velocity decreasing at a rate of 5 feet per second So when is it going down at a slope of 5? Okay, looks like the only time that happened was here. This is steeper than that. This went down 10 in 1 second. This went down 5 in 1 second. So from 0, sorry. So from 1 to 2, we have that occurring. Okay. Oh man, forget that. Okay, here we go. Get a new one. There you are. Okay, so the only time this happened, I already forgot when it was. All right, from 1 to 2. Yeah, from 1 to 2. And we can talk about that one a little bit more tomorrow if we need to. Less than t, less than 2. The slope is -5. Okay, I did it. All right, now this all was new as far as the typing on a PDF, but made it work. And now I'm in the dark. It's kind of scary. See you tomorrow.